Okay, so it's something like this. We have the okay. So we talked about Java as a language and Java as a platform. Now, normally, let me try to make a comparison between how we uh, perform our, we want, what's the main purpose? We want to develop some kind of an application, solve a problem. Okay, so you would write some code in the language, and then what's the first step you do? Let's say you are doing it in C language. I want to make some comparison. So let's say you have a program in C. Yeah, what do we do with that? Your machine won't understand the C program. So what do we do?
We convert the program to
Right?
assembly.
So we have a compiler, right? We use a compiler, compile this Java code, and the output of compilation, okay, would be some kind of an executable code. Okay, so we get an executable code. Okay, and what is this executable code? Coming. Yeah. So what is this executable code made of?
Consists of the assembly language instruction sets.
And it's made up of instructions, right? So this is made up of instruction. We say it's a machine language code, or fine. So this is made up of instructions, which will be followed by, oh, how does, so here is a compiler, right? So we have done a compilation here. Okay, so what's the code which is generated? This will be according to some target machine or platform. Okay, this is according to some platform. The platform on which you are compiling, for example, you have a C code, you compile it on Windows machine. Then the executable which is generated will be having instructions which is understood on the Windows platform. Same code, same C code, you can take it, compile it on another machine which is a Linux machine. The output of compiler is different, because now the output, the instructions which it has to, because it is creating a code, fine, it's a low level code, right, which is ultimately it's supposed to run. It will generate a code which will work on the Linux platform. So according to the platform where you are compiling, your output is different for the same C code. Okay, fine. So if I want to make a comparison with Java, okay, here is your Java code. Okay, and when we compile, the output of compilation is again made up of instructions for a platform. But which platform are we talking about now?
Now we talk about JVM.
It's always the Java platform. Any Java compiler, you may be working on, you may be compiling on any platform. For a given Java code, the compiler generates the same output. It does not depend on where you are compiling. So from that point of view, yes, this part is platform independent. But we understand, so this has generated, now what is this executable has been given a special name. Okay, we call it as Java bytecode. Okay, this is what we call it, the Java bytecode. Okay, Java bytecode is nothing but low level instructions for the Java platform. Okay, so the difference between executable here and this here is, this executable will work on which platform? In order to execute, how do we execute? It will execute on some kind of a platform. Okay, so let me say this is the platform. So the platform on which you had compiled, the same platform it would be able to run on. So you have to look at which is the platform for which this is generated, and you'll be able to run it there only. Whereas in case of Java, what we have is, now comes the important part. We have this is where we have what we call as a JVM interpreter. So you will have a JVM interpreter here. So we have a JVM interpreter. What is the role of the JVM interpreter? Reads your Java bytecode, and they are the instructions for the Java platform. Okay, so this is a link between the platform on which you are actually wanting to run and the Java platform. Okay, converts your instructions from the Java platform instructions into the native platform. We'll use the term native platform. Okay, and so native platform is where it would run, right? So here is the native platform. Okay, fine. So here it has to execute here. Okay, and this one is going to interpret. Okay, so there is an interpreter which will interpret. Okay, so the code will have to be interpreted, fine, into the native platform so that it can then execute. So we say Java is just a platform, right? So okay, so you can understand. Okay, only the thing where we can say it is independent is the compiler. Output of compiler is independent of the platform. And so relation between Java as a programming language and Java as a platform. There are two aspects that we should always remember, right? And so that explains mainly about platform independence. The term platform independence, when someone is saying, oh, Java is platform independent, basically this is what is the difference. This is what is to be understood there. And so any questions here?
So in Java, the output of the same program will be same for all the like Windows, Linux, and Mac.
Okay, fine. See, if you write a program, and let me say you are writing Hello World application to print Hello World. If you write it in C language, you compile it. When the output of compilation is an executable, okay, so that would work on which platform?
Particular.
And that executable, we are not talking about the C language code, that Hello World code. You take that same Hello World code, compile it on a different platform. The output which is generated is different from the one which is generated on Windows, right? Okay, so when you compile, the output of compiler is dependent on the platform. In case of Java, the output of compiler is independent of where you are compiling. The compiler on C language also will generate, for a given Java code, will generate the same code as what is generated by someone who is compiling on a different platform. So if you consider this is a executable, right? If this is an executable, okay, but this executable doesn't run straight away. It is dependent on a interpreter. Okay, it requires an interpreter. So if I have compiled for the Java platform, okay, that code would run on any platform which has an interpreter for it.
Java is platform independent because it has its own platform.
It is a platform. Rather than saying platform independent, Java is a platform. Okay. Okay. Fine. So clear on this aspect? Okay. Fine. Next. So platform independence is one thing. Yeah. Okay, so yeah, so a little, only a quick find, because this is something which you should be able to find anywhere. If you search, you can always find about the history of Java. So I'll not spend much time about history of Java. I'll just make a few statements here which are related to Java history. Or find just a few things, few information related to Java. I have to put it here. Let me put it in the text here. So yeah. So a few information. One of the things uh, which was, I think it was answered, was related to, oh, who developed Java? So it's a Sun Microsystems. Okay, name of an island. Okay, I'll just quickly just like someone said, name of an island. Another thing, what is whenever you find any book on Java, most of the time you'll find a cup. It's a coffee cup. So what is Java here? Java is also name of a coffee brand. There's a brand called Java. Okay. 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 And yeah, in India we also have a. There used to be a bike called Java. Okay.
They recently came back into market.
I said they have come back in
Yes.
Java's
From
popularity.
new models.
Okay. Okay. Fine. So fine. These are just some of the things. Anyway. Yeah. So about Java, right? Okay. So initially developed by Sun Microsystems. Right? Okay. And in Sun Microsystems, uh, we had a scientist there, okay, who was leading this project, and his name is James Gosling. Okay, and he is known as father of Java. Okay, Java's birthday. Okay, Java was basically Java was initially. I'll tell you, there's a date here which we call as the birth date for Java. I'll first put that. So, 23rd of May, 1995. Okay, that's Java's birthday. Okay. The significance of this date is that this is the day on which Sun Microsystems has demonstrated something which was unique in those days. Yes, now it's not unique any longer. But what was unique was they demonstrated the use of, which is something which is no longer relevant and not going to work. They demonstrated applets. They demonstrated how it can be used on internet. Okay. So if you want to just get a quick view on how applets work, just very quick, the mechanism behind applet and how it was so unique. Okay. Fine. Let me come back here. So if yeah, one thing we understand that what is needed to run a Java application, any Java code, we need a JVM interpreter. Okay? There has to be an interpreter that is necessary, or you may call it as Java runtime. Okay, there is an environment, we call it as Java runtime environment, which is needed for, and anytime you would like to use a code which is written in Java, if that has to be executed. Okay, so fine. Now just a very quick look at what is applet, right, and how it was demonstrated on that particular day. So they had demonstrated the use of applet on this date. Okay, so what was done for that purpose? To understand that, because now it involves use on internet, right? Okay, how Java can be used on internet. Uh, let me also give another, at least the year part. Okay, this project called, which is for the Java platform and the language, the two together, that was initiated in 1991. So it had started in 1991. It's only after the demonstration of this applet that Java became popular. So applet has a role in making Java popular. Okay, fine. Okay, so from that point of view, let's just have a look at, yes, it's no longer going to work. Fine, it's the programming interface related to the applet has actually been getting removed from the latest versions. Okay, new versions of Java are saying, okay, we don't want to now have, because it's not going to work now with the latest versions of the browsers. Okay, fine. Okay, let's see. Okay, so from the point of view of use of applet in internet, so how do we use internet? What's the primary thing on your machine which you use in order to access the internet? We use a browser. Okay, so yeah, let's say we have a browser here. Okay, and in the browser there's something very important. We have a bar, right? What do we write in that? We give some input to the, we give a URL. Okay, so we have a URL, right? Okay, so a typical URL, how does it look like? Okay, so even before that, something else. Let's say, okay, HTTP : / and then okay, okay. So maybe Java. Oh, I'm writing a very old URL, may not work now. Something like java.sun.com / then
maybe home.
there might be some kind of a path here, and at the end there might be some file name, okay, which ends with .html. Oh, I'm talking about the old days. Okay, this is something which was done in 95. So yes, normally you will just have HTML. So but we have to keep in mind that perspective. We are talking about 1995. Okay, so if we have this, right? Okay, so if you look at this URL, what happens when we give this input to the browser? What exactly happens at that time? What will the browser do?
Browser will load particular website and
So in this, can we divide it into smaller parts? Yeah. The domain, fine. This is what is identifying a host machine. It identifies on the internet somewhere there is a machine, fine, which corresponds to this. This will get interpreted into, it will identify what is the IP address, where is that. So it locates. So first thing when we give is it has to locate, oh, which is that machine, right? Second thing it will look at is, oh, it looks at this. Okay, fine. In absence of what we call as a port number. So there's something like a port number. There's a machine and there's a host and a port number. Okay, uses this much information. So first thing here, it has identified, oh, there's a machine here which corresponds to java.sun.com, whatever that domain you have specified, right? And you have to, this browser is a process here on your local machine, okay, and this needs to get connected to some process on this machine. Which process? It's the HTTP server. Okay, someone who will understand the HTTP protocol. Okay, so here let's say this is my HTTP server. Okay, so we have a HTTP server on this machine, right? This is a machine. This is identifying a machine, fine. and then it makes a connection to this, right? So here the browser is going to connect to this. Okay, establishes a TCP/IP connection, and on this connection sends a request. What is it? What is the request which is going? The request simply says, you please get me. Okay, it says get. Okay, get me. Or what do I want to get? Oh, this is what this part here. This is what you have asked it to get. Okay, fine. The file and the path. Okay, path to a file, you can say. Okay, so this path, whatever you have given, fine, that information is sent here. So initial part used to make a connection, right? Port number is identified by, if not mentioned, it will be identified by the protocol. And then, of course, according to the following the rules of the protocol, it has to send a request saying, okay, I want to get this. Okay, so that is a resource. This part we call as the resource. Okay, resource on that machine. Right? Okay, so yeah, what will the browser? So what will the server do now when it receives this request? Oh, it has to look at that request. So most of the time, corresponding to this path, whatever has been sent, it would have identified a file which is an HTML file, okay, which has the HTML content in this, right? It would identify this. The servers, now the job is on the server side, okay, and then what will the server do with this content of the file? Give it back. So he's responding and saying, okay, here is what you had asked for, right? And what does the browser do with that content?
Will display on.
Right? Display, or we call it as render. Right? It has show. Okay. It starts rendering the content. Okay, and rendering HTML has its own set of tags, and those tags is interpreted by the browser. It fine, shows them fine, oh, something is required to be bold. Yes, it will do that. So browser understands those HTML tags, and one of the kind of tags. Now let me talk about one of the kind of tags which was commonly used, and which anyway everywhere you will find. There is a tag called image tag. We'll say src equals, yeah. So there is in HTML we have a tag for the including the images. So we'll say, okay, image src equal to, and there'll be something, maybe some GIF file, JPEG file, maybe. Okay, and there might be some more information. That's it. Okay, fine. Which is one of the tags included in the HTML. So when the browser is receiving this kind of an HTML, there is a tag which says, oh, there's an image which is needed. What will the browser do with that? It's what it has received is only a text. HTML is simply a text. Okay, so it has received a text with the tag. What will the browser do with this tag? It doesn't show you the tag. It has to, so it has to show the image. So for that, what will it do? Where is the image? It has to make that same connection. See that connection which has been made? Earlier it was asking for HTML. Now on that same connection it will say, oh, give me that JPEG file. Okay, sorry, JPEG file. So give me the JPEG file. Uses the same connection, says, okay, give me the JPEG file. I need this JPEG file. So browser will locate the server here, right? The server will locate the JPEG file, right? Content of the JPEG file sent back, and that's where he is going to render it. Hence that image will be rendered here, wherever according to. So image is getting rendered, right? So what Sun Microsystems did is they said, okay, well, just like we have an image tag where an image can be shown inside a browser, right? So browser was capable of understanding and rendering all kinds of images. It might be JPEG file, it might be GIF file or whatever, right? See, this JPEG, GIF file, they have a standard format. It's the same every time. Okay, the format is the same, right? It doesn't change for Windows platform or for Linux platform. Okay, so now they said, okay, just like that, why can't we keep a tag like image tag? We can have a applet tag. So they said, oh, we'll have an app. So what they introduced, what Sun Microsystems introduced, was a tag called applet. So they modified one of the browsers and said, okay, let it understand the applet tag. Okay, so applet would say, okay, code equal to, and here it would refer to something which is the Java bytecode. This is something which would refer to a Java bytecode. Okay, so here again, similar to what was happening with the image tag, when a HTML is received with a applet tag, what will it do? Make a connection, ask it for the Java bytecode. Okay, what will be sent will be the Java bytecode, which is a standard format, does not change according to the platform, right? So what is needed in the browser now for the applet to work? JVM. So we say, oh, the browser must be Java enabled. Oh, Java enabled means, oh, it has a JVM interpreter. Okay, so this is what was initially demonstrated. This was demonstrated by Sun Microsystems on that specific date, 23rd of May 1995, and that's how we say, oh, this is the birth of Java. Okay, and those days, yes, the internet usage was all, plain HTML with images and maybe audio, some such resources, but never a program kind of a thing would travel on the network and run on the client side. We'd say, oh, we have a server and here is a client. See, what is the thing which is offered here? You go to any part of the world, right? Right? Carry your whatever, any platform you may be having for your client side. You just need a browser which is Java enabled, and you should be able to run your client code on your machine. You don't have to carry the client code on your machine. You can pick up any machine and just work with that same client. The client code is going to travel from server to the client, and then after coming here, yes, it is free to make a connection to the server side again, and fine. So this is a Java code which travels, and the client side of the Java code is going to travel on the network and then work on the client side. Okay. Fine. So it's interpreted. Fine. So this is the main reason how Java started becoming popular. Okay. So those days, yes, initial days of Java, oh, everyone would, instead of saying teaching the whole language, they would start with applet, basically. And if you come across, if you put your hand on any old book which was meant for Java, most of the time, the second or third chapter itself, they'll put applets. Okay, they'll start with applets. So it was thought everyone wants to learn applets here. Okay, but yes, Java is not just about using on the internet. Java is a general purpose object-oriented programming language. Okay, fine, which can work on, so you will have a JVM interpreter to make it work on any platform. Okay. Fine, clear about this? Fine, so any questions till now?
What does the difference between like HTML and the applet? Like basic difference, like does it reduces the number of requests sent to server and all that, or does it make simpler than this?
Okay, fine. You want to know about what is applet for, right? HTML is a plain text
Yes.
which has
Properties
tags.
and-
And the browser's role is, okay, I'll be able to interpret and render it, show it, right? I should be able to show anything, right? So applet was a special kind of a Java code, okay, fine, which was basically one GUI. It's a GUI component of Java, okay, fine, which the browser is designed to understand. The browser has been designed to understand that this kind of a component can be there. Once the component of applet has been created, an object of the applet has been created, there is interaction. There is a standard way of interaction between the browser and the component. So browser has to initiate the component and say, okay, you are here. Fine. If you want to talk to me, if you want to use my resources, I'll give you a component so that you can use my resources. So there is a proper initialization for the applet which has to be done. So which we say, oh, we have a life cycle. Okay. So there is a life cycle for a component. So applet is simply a Java component, okay, which would be created, initialized, and used in the browser, but no longer available. Okay. Right? I mean, these embedded technologies, they all have been removed. Right? So even after this HTML5, not HTML5, this is, we have HTTP2, you can say, HTTP 2.0. Most of the embedded things have been removed. HTML CSS 2, HTML5 CSS 2. Yeah. Okay. So they have got rid of most of embedded. So even there used to be something called Flash for multimedia. That's no longer supported. Okay. And so, and even for .NET platform, there was something. I don't remember the name, but yeah, we have such embedded things which were so. But one thing, pioneer is Java. Applet is the pioneering thing where this kind of embedded things were there, where a code could be embedded into your browser. Right? Okay, and so we understood about the and clear that platform independence helps it here. Okay, standard.
Because the browser can be on any machine.
Browser on
Some
any
user
machine.
is using browser
Yeah.
on Linux, some user is using
On Windows. Yeah. Okay. Fine. So this aspect is clear, right? Okay. So, okay, let's now move on. Okay, let's go back. Okay. So Java is a okay, applets. I think we're fine. So applets is something which we have now understood, got a little idea about. Okay. There were other things also like applet, there is servlets, so many other technologies have come. Okay, servlets are still existing. Okay. And so because they are on the server side, okay, there's nothing about embedded. Okay. So
this Java's birthday,
yeah.
it means that the version 1
No,
was
not
released that time?
no. Version 1.0 official version is a later one. Yes, it's 98 or something. No, before 98. 90. Yeah. 98 we had a Java version 1.2, or you can say Java platform 2. See, one thing, for every release, you find both of them getting updated. So each time a new language specification has come, there's also a virtual machine specification corresponding to it, which is coming. But two separate specifications being managed. So they are two separate independent things to be understood separately. One is rules for the language, how you can write your code. Okay, that's a language specifications. Right? And okay, I'll just give you a few more idea here. Okay, just a little more points here. Java is not the only language to work on the platform. So any other languages people know about? Any of you know? what are the other languages available for the Java platform? Okay, Python is popular. So there is something called Jython, which is Python for the Java platform. So this is available for to work on this Java platform also. Okay,
So the syntax will be the
syntax is
similar.
Python. Syntax is Python. Okay, it's a language, right? Okay, we have Ruby on Rails. There is JRuby. Okay, there's something I don't remember the name. We have Scala. Okay, and we have something like Clojure. Okay. So these are different. So there are like this. There are number of there are number of programming languages which are available on the Java platform. Okay, fine. They say there are more than 100 languages. We understand there's a language which is going as a research work by so many people. So there are so many n number of programming languages. Only very few become popular. Okay, fine. So there will be a lot many such languages, okay, which will be on the Java platform. Okay, fine. So yeah, now the next important thing to understand is uh, about object-oriented programming. Okay. So what do we understand by object-oriented programming? See, one of the important things which you will deal with in any programming is data. Yeah, we deal with data all the time, right? So we have instructions which would manipulate a data, right? We have instructions to manipulate the data. How can a data be manipulated? When we say, oh, I will be manipulating data or maybe using data, yeah, what is it that we have to do? It depends on what kind of data it is, right? Oh, we have got these operators, right? Fine. Oh, if it's a numeric type, I can do addition, subtraction, multiplication, division, and so on and so forth, right? If it's a string data, I can do concatenation. Maybe I can take out a subpart of it, substring. Right? See, it all depends on. So we have something called different types of data are available. So every programming language deals with what we call as a data type. Okay, so we have got data types, right? Yeah. Okay. Different kinds of data types are available for a platform. Okay, fine. So, so when we talk of data types, we also, I think what we also need to relate with the data type is the operators available for the data type. Oh, different data types and a language is providing us with the operators, which can be operations rather. I'm not just saying operators, I'm using a more general term called operations. When we understand, language formally uses data types and operators, right? Okay, so yeah, and you were normally dealing with numeric types. Most of the time it was about numeric type, but nowadays, yes, we can deal with other data types as well. Okay, we have text. Of course, everything ultimately boils down to be a number only somewhere. Okay, even your text is a number, right? It's all made up of numbers. Okay, or so even if I'm talking about an image, it's made up of numbers. Image is also a type because that's data for me. Okay, there's an image data. So data will be of all different kinds of things. Okay, see, different type means it's up to you how you identify that type to be, right? Okay, let's see. So yeah, so data types and I'll say operators. Okay, so in general, I'll not use the term operators, but I'll say operations. Okay, on data, fine, depending on its type. Okay, so data will be of a type. Okay, and what can be done on a type, on a data, depends on what kind of data it is. Okay, so we have a relation between data and operations. Okay? Given a type of data, so instead of talking about data, we can talk about types first. We understand difference between data and type. Everything is of some or the other type. It's just a classification, right? It's a way of classifying your data. Oh, this data has been classified as numeric and text and image and something. It could be. So it's just nothing but your way of classifying things. Right? Okay. Right. So whenever we talk of classification of data, we talk about data types. Okay. So what is different, right? So every time in any language, we are going to be dealing with data types and we are going to be performing operations on data types. On data, and what operation we perform will depend on the type. So keep this in mind, right? Okay, that yes, we have. So okay, now I'll just show you the, in various these generations of the programming languages, the aspect which has changed related to the data type and operations. Okay, right? The data types and operations. These are the two things we would like to look at. Okay, so we have. Okay, let me put like this. Generations mean I'll say, okay, we have low level languages. Okay, and after that came the higher level languages. Lower level languages, when I say it's machine language and the assembly language. Okay, we have the higher level language. Languages like C. Okay, and then I'll say the next language would be the object oriented language. Okay. Okay. So there, yes, we have various kinds of object-oriented languages. Okay. Now here, let me put it like this. We have data types and let me try to classify some. We have operations for the data type. Okay. Now, why I'm looking at the different generations of the language, when we had low-level languages, okay, the data types available for us were defined or they were fixed by the language. They have been fixed by the language. Language has given us an instruction set. Here it was all about a instruction set, the assembly language, you have a, or a machine language, you have an instruction set, and each of those instructions in the instruction set, or they would be either a flow control instruction, or they would be data manipulation instruction, or reading the data, some fetching data related to data, right? So so the, I'll say, the data types were fixed by the language. Okay, and we had a fixed instruction set, and therefore we'll say, oh, even this was fixed. The operations available were fixed by the language. Operations available for the type. Okay, I'll say, right? It's when I'm saying operations, it's operations available for the type. In case of higher level language, okay, language like C. In C language, data types, are they fixed by the language? We do have things provided by the language, but if we want, we can create our own data types. We can use type def, we can use struct, union. C language has ability to create, which gives you, okay, you can create data types, right? So here, this is not fixed, we'll say this is programmer defined. Okay, what about the operations for the data types? They're still fixed by the language. Okay, so language has fixed the operations available for the data type. What is object-oriented programming? It's all about programmer being able to define data types. Okay, and what about the operations for the given type? Even the operations is something which the programmer decides now. For a given type, okay, what are the operations available is defined by the programmer. Okay, so that's how you look at the, and so yeah, thing about the object-oriented programming is data types as well as the operations for the newly defined types, okay, which a programmer is defining, is decided by the programmer. So he can say, okay, oh, I have a type called date. Date is a data type. Of course, it's made up of numbers ultimately. Everything is boiling down to number at the end, because yeah, that machine is a digital machine dealing only with numbers. And internally, it has to deal only with numbers. It doesn't know anything else. Fine, but okay, fine. So okay, so fine. I think this is which is understood, right? Any questions here? Fine.
Like,
yeah.
I can understand like data type statement by program and object oriented. How does like operations are different? Like for
Okay.
the let's say numbers, there are
Yeah.
summation,
Okay.
division.
So see, okay, okay. I'll just also put another thing here. What is a data type? If there is a data type, means
Defines the data number, textual, or let's say yes
Huh.
or no only.
So you have a type. That's first thing.
Yes.
And if there is any data type, I should be able to use. I should have values. I should have variables. I should be able to declare variables in my language. Every language, oh, you have a variable, right, which is very much used, and you say, oh, this variable is of a particular type. Okay, so if I am saying I have a type date, okay, I'm saying I have got d1, I've got variables d2. So you declare variables of a type. Okay, and the operations on this d1 dot next date maybe, and I might be able to say this date D2, D3 equals something like that. Next date is an operation available on the type date. D1 is of type date, and therefore I can use the operations which are available for the type date. Because of the type, if it was a string type, I won't be able to say next date.
There are certain.
I have to look into the type to understand what can be done. Data is of a type. What operations you perform depends on the type. So what is important all the time is to know what are the types and what operations available for a type. Okay. See, entire Java programming you'll see is all about this only. Right? The Java programming language is all about understanding types. If you understood types, you understood any programming language. Just concentrate on the types. Python, it's all about this only. Okay. Otherwise, other things are the flow control. And flow control, how the program flows. Okay. You can have iterations, you can perform iterations, you have the loops. Yeah. But yeah, you want to do something, some operation to be performed repeatedly. Okay. So, I want to do a repetition. Right? I must have flow control for that. Right? I want to do something conditionally. So, condition checks. And so, languages, programming languages, and they, but main thing is you are. So, when I'm talking about object-oriented programming, right, and a language like Java, in fact, in Java, you're only going to be creating data types. You're only going to be creating data types. So you'll see that. Right? It's all about types. Okay, fine. Now, just a little about the object-oriented way of thinking, looking at the things. Okay, so with it's these operations. When I'm saying operations, we are saying they are also, you may call them as interactions also. Interaction. Fine. D1 here is an object. D1, D2, we say, oh, they are objects. Date is a type. In object-oriented, a specific term has been used, we call it as a class. Okay, and that's just different. There are different kinds of data types, you can say. And so you have class, someone will say, oh, we have an array type. Right? Programming language will have arrays also. So that's again a type for me. And so everything is a type. Okay? And what you can do, how you can use it, oh, because it's of this type, I know how to use it. You'll have variables, right? And they will be of a type. Of course, there are languages where variables do not have a fixed type. Okay, so Java is a strictly typed language. Java is a strictly typed language. That means you have something called expression. Okay, every expression used in your program has a type which is known to the compiler. There's nothing for which the type is not known to the compiler. And when someone looks at the program, when each statement independently, yes, the type will have to be identifiable. Type for everything has to be identified. Okay, fine. Okay, when we'll come across at this classification thing, we'll see something more. Okay, now, okay, let me now take a small example and a small example to understand the way object-oriented programming actually, how you can think in terms of object-oriented programming, fine? Because it's all going to be about designing your data types. See, the whole difference is as you go ahead, right? As you go from progress in these generations of the programming languages, and as you move towards this object-oriented, it's giving us more responsibility. You didn't have the responsibility of defining the types. Here, it gave you the responsibility, the programmer here, I'm saying, right? He gets a higher responsibility. He is responsible for the types he is defining. He is also responsible for the operations which are available, he is making available for a type. You could always pass on to, okay, oh, this programming language doesn't support this or it supports this. But now you don't escape that way. You don't have a type, create it. And when you create a type, your role will be to identify the proper operations which should be available for a type. Okay, fine. I have another simple example to understand what are to think in terms of object-oriented programming. It's all about solving problems. In object-oriented programming, we're very in the real world, right? How do we solve a problem? And we'll look at that aspect. How do we solve a problem and relate it to this object-oriented way of thinking here? Okay, so let's look at something here. So the object-oriented way of solving a problem, right? To understand that, let's take a simple example. A simple problem is here. We have a friend in Kolkata. Okay, we have a friend in Kolkata, and we want to send flowers to our friend who is in Kolkata. Okay, how do we go about that? Oh, we are in Baroda here. So how do we go about that? Okay, let's not assume about internet things. Let's be in the real world instead of the making use of the virtual world here. Yeah. So how do we go about that?
Somebody local or somebody local in Calcutta.
We don't know anyone then. But we know people in Baroda. We can take help of services available in Baroda. Yeah. So where will you go?
Courier.
You want to courier flowers? Want to courier from here? Okay.
Somebody is going to Calcutta.
Okay. Fine. So we may not find each time. So what we have few standard services. Okay. For example, you might go to someone here in Baroda. Let me give that name. So we have someone in Baroda. Let me say this is JK Florist. Okay. So we got a JK Florist in Baroda, and you will go to JK Florist and you will have an interaction with JK Florist. What is the interaction? So we have an interaction with JK Florist. Yeah, what is that interaction?
That we want to send flowers to.
So yeah, so the interaction is saying send flowers. Okay. Yeah. Well, just saying send flowers. When you say send flowers, you will also need to provide some information. Send flowers is the verb, is the operation, right? But it requires some more inputs. Yeah. What else will you specify?
Name.
Right? You'll have to specify the name and address where it is to be sent. So you have the name and address. What type of flowers you would like to send? Right? The type of flowers. And you will also specify the quantity maybe. Right? So some such information will be there. And that's the interaction with JK Florist. Fine. You make this interaction with JK Florist. Right? Okay. When you've done this interaction with JK Florist, what will JK Florist do? He is in Baroda. So first thing, all the time, whenever someone says send flowers, he's giving, going to say the name and address is going to be provided to JK Florist. What JK Florist does is he always looks at this name and address. The address, oh, this is not a local address. Is it a local address or it's not a local address? That's the first thing he'll check. It's not a local address. So what should I do? What will JK Florist do when he sees it's not a local address? He says, oh, where is it? It's Kolkata. Then he has a diary where he's got city-wise contacts. Okay. And who can do the job for him in that particular town? Right? Okay. So he refers to that diary and locates that in Kolkata, I have got someone called KK Florist here. Okay. And then he will also have an interaction with KK Florist. He knows about that from a diary and says, okay, let me now connect to KK Florist. So he will connect and interact with KK Florist. What is the interaction here?
Similar, like
Same. So he again says send flowers, right? This exact information, he's saying send flowers and passes that piece of information to KK Florist. Okay. So this is an interaction with KK Florist. And what will KK Florist do? So what will he do? Okay, always look at name and address. First thing, look at the name and address. This is, oh, it's not an outsider, it's a local address. I don't have to look into any diary now. But yes, and next thing I'll look at is the type of flowers. Oh, what are the type of flowers needed? Okay, and for this type of flowers, who is the flower producer? Oh, we have a flower producer. Okay, so he would then interact with locates a flower producer for the type of flowers. Depending on the type of flowers, and he has a diary where he's got type of flowers, this type of flowers, who's the flower producer, right? Which are local. Okay, so he interacts with a flower producer. What is the interaction here?
type of flower and quantity.
Yeah, the interaction will be get flowers, right? He says get flowers and passes the information, which is the type of flowers and the quantity. So in this interaction, he'll get back the flowers, right? He gets the flowers from a flower producer. Next, he's got the flowers, he's got the name and address, he's got the flowers. Next, yeah, he will deliver. He will leave his shop and go.
Send flowers and the address.
So he will have to interact with a delivery boy. So there is a delivery boy here. Okay, fine. There is a delivery boy and he interacts with the delivery boy. What is the interaction here? The interaction is deliver. And delivery boy can deliver anything. So he is given the name and address and the flowers. Name and address and flowers are given to the delivery boy, and then the delivery boy goes and delivers to your friend. Fine. Okay, so we understand that there is interaction which is involved, right? To solve a problem, yeah, we will have to collaborate. There's collaboration needed, right? There's all of these will have to collaborate in order to solve a problem. Ultimately, yes, you wanted, it's you who started, and at the end, it's your friend who is receiving the flowers. Okay, but in between, yes, what all things are involved, right? Okay, so one thing, your first interaction was you went to JK Florist. You went to JK Florist and said, send flowers. JK Florist understands send flowers. Why? Okay, I'll give you another hint. Because
Like he's associated with the
hmm,
flowers and all.
huh,
He
huh,
knows
huh,
basically the instructions.
huh. You won't go to, if you go to Mochi or you go to that, your grocer, and just say send flowers, will he understand send flowers? No. JK Florist understands send flowers. KK Florist also understood send flowers. Why? Because they are florist. They are of type florist. Florist is a type. What is JK Florist? What is KK Florist? They are the objects. JK Florist and KK Florist are objects. Right? You perform operation on an object. What operation? What will he understand? It's an interaction. When I'm saying operation, it's an interaction. Right? Interaction with the object. Object is of a particular type. And depending on the type, you know what he will understand. What is interaction you can have with the object depends on the type of the object. Okay, fine. This is what is to be understood, right? So, when we say object-oriented programming, we are saying, oh, programmer can define his type and he can define the operations for the type which he is defining. You don't only create a new data type, but put the required operations for that data type. When you are defining a class, okay, yeah, we'll have something called a class. You are actually creating a new data type. You're just creating a new data type, defining a type. It's a definition part. And it has nothing to do with how things happen, right? It is something which will be used by someone else, right? Someone will have to say, okay, let me have an object of this type. And if there is an object, I should be able to use this. The class definition is simply a definition and not something which is real. Real thing is the objects. Okay, we say class is a blueprint, right? It's simply a blueprint, and according to which the object interaction has been defined. It's mainly defining the object interaction aspect. Okay, fine. Now one thing here, so we understand relation here. This is an object and we have a class. The class is, there is a class called florist. Florist. Okay, we have a class called florist, and okay, same way we have a class called flower producer. There's a separate class called delivery boy. And these are types. Okay. Then instead of DB, I should actually return some name. Who does that? Right? Here also. Then it becomes an object. Okay. Type is flower producer. Flower producer is a type. And the actual one who is doing it, right, who is producing the flowers, there will be so many people who will be doing that. but all of them follow a particular set of instructions. Okay. So any questions so far? Okay. Fine. Now, okay. Now we can have an interaction with JK Florist, which is saying send flowers. That's one thing. Okay, but with JK Florist, we can have still more kind of interactions. The other interactions which we can have with JK Florist, for example, you will have some kind of a commercial dealing with him. So there is some interaction which says, get me a bill. Fine, to fetch the bill from this. So you'll have interaction which requires get me a bill. Okay, there'll be another interaction which says accept this payment. Then getting bill, accepting payment, getting bill for the service, accepting the payment. It has to accept the payment for the bill which he has given. Okay, so we will have more interactions possible with JK Florist. But I find that this kind of interaction is also there with my grocer. And I take something from him. He has to give me a bill, and he will be also accepting the payment from me. So we do have interactions with grocer which are of the same kind as what we are having with JK Florist. It's same as what we will be having with so many other things. Okay, so JK Florist understands send flowers because he is a florist. JK Florist understands get me a bill because he is a shopkeeper. All shopkeepers understand getting a bill, accepting the payment, that commercial interaction for the products, okay, which you are fetching from, buying from them. Okay, so yeah, so we have this, but there is a still bigger thing than florist. I think I should rather okay, and put it separately. Okay, and that part is okay, and then we'll keep coming back there. So we got an object which is a JK Florist. He is of type. So the type is florist. Okay, so that's the first thing. He's a florist. Okay, but there's exists a still bigger type, right? Which is the shopkeeper. Shopkeeper is a type, and you'll see that florist is a shopkeeper. Florist is a shopkeeper. So anything which is meant for shopkeeper, any kind of interaction which is available for shopkeeper is definitely available for florist. Okay, and so we can have an interaction which is related to a shopkeeper. Okay, also you can go to JK Florist and say, how are you? That's another interaction with JK Florist. JK Florist understands how are you because he is a human. Okay, so we have a still bigger type. Okay, there's still bigger type, fine, which is called. So there is a still bigger type here, and I'll put it as we have a bigger type called human. And here we have the shopkeeper. So we have a type called human. All human will understand, and we have a list of interactions which is for all humans. Okay, fine. We have specialization within the human. Oh, these are the shopkeepers. Okay, if someone is also a shopkeeper, right? Some human is a shopkeeper. So all shopkeepers are human, and that's what we are saying. Okay, fine. In the virtual world, that may not be the case. Fine. In the real world, yes, that's what the case is. Fine. Okay. Uh, fine. So we have a set of interactions available for shopkeeper. Fine. So any shopkeeper is a human, and therefore he understands any interaction which is defined for human. Same way, any interaction which is available for shopkeeper is definitely available to the florist, because florist is a shopkeeper. We find this as a supertype subtype relationship. These are types. Okay. Which is the supertype here in these three things? Human is the supermost type. Right? A subtype of human is shopkeeper. A subtype of shopkeeper is florist. Okay, fine. What we find here is that a subtype has more functionality compared to the supertype, because subtype is going to inherit functionalities of its supertype and then can add more functionality, right? It can add more functionality. Okay, this is what we call as inheritance. In object oriented programming, we are talking about inheritance. What is inheritance? In a programming language point of view, what is inheritance? From a type, which is existing, I should be able to create a new type which inherits the interactions available for the supertype and should be able to add more functionality if required. Right? See, it's all about defining new types. Now we are talking about being able to define types. So inheritance is nothing but being able to define a new type which inherits from some existing type, which we call becomes the supertype of a new type. Okay, right? So if you are thinking in terms of, because object-oriented programming will always say, oh, we are talking about class, right? Class is what is a class? It's a data type. When you're defining a class, you are creating a new type. Okay, so I want to create a new type, but I'm defining a new class, but let me inherit from some existing class. Okay, fine. So our object-oriented programming, any object-oriented programming language offers us this kind of a thing. But is this something new? Supertype, subtype, because class is after all a type only. Is this a principle of supertype, subtype relationships something new? Or was it there in C language? It's there in C language, right? No? It's there, right? You have something which is of type long. Yeah. Okay. So long supports some set of operations, right? Oh, what does it support? Addition, subtraction, multiplication, division. Right? And see, when we talk of supertype subtype relationships, okay, if I consider the type from C language, right? So maybe many times, where do we use data types? We use at so many places, right? How the type is used? Maybe I'm defining a function, okay, and it has a parameter which is of a particular type. So if I'm having a function says, oh, this function is defined for the type long. Okay, I have a variable a, right? So in this, I know within this function, I will be using on a, I'll be using the operators available for the type long. Fine. Okay, and if I am having now, so how will I use that function? F and pass a value which is of type long. Okay, so if I have got int x, right? I have got int x, and maybe it has some value, but the type is int. That's the point here. Okay? If I say f of x, is that valid? The type is int. Is this valid or not? It's valid. Int is a long. Right? See, all the int values, they have a smaller range compared to the type long. Fine, compared to the type long, they have a smaller range. All ints are long, that way they can be used as long as well, right? So every int qualifies as a long. Okay, fine, and therefore I can use this. For long, for int there is something additional compared to long in C language. For example, the increment decrement operators, they're not available for the type long. They are available only for int. Oh, we write switch case. Right? It's available for the type int, but not for the type long. So how I can use int? Oh, there are more cases where I can use int. But wherever long is available, I can always use an int there. Yeah, so this is not a new thing, inheritance. Super type subtypes exists. Yeah. Okay, it's just okay that when a programmer is, it's all about programmer being able to define a new type. And when you define a type, okay, I can create a subtype as well. So creating subtypes. Right? Okay, see here I can be sure long is there, and because the type for A is long, there won't be anywhere in this which says A++. Okay, you may be passing a int, but that's fine. You are using whatever is for long, and int has more functionality compared to long, and we can see that. Okay, and so relationships were existing, super type subtype relations were existing even in the C language. Okay, and it's all, so inheritance is about super type subtype basically. Okay, when clear about the principle of inheritance, super type subtype relationships. Okay, next and okay, the relation between object and class. Yeah, I'll use the term class now. What is the relation between object and class? We say object is an instance of a class. Okay. Object is nothing but an instance of a class. There can be multiple such instances for a particular class. Okay, and you may have a class, you may not have any instance for that class, that's also still fine. You may have any number of instances of a class. Okay, fine, but yes, be aware there can be classes for which there are no instances. Okay, super type subtypes is going to open up a lot of things anyway. Okay, fine. So from object oriented programming point of view, there are things like this. There are few terminologies. Sometimes some of the terminologies may have been misrepresented in many of the texts. Okay, fine. People have created their own interpretations of the word. For example, when we talk of object-oriented programming, we talk of abstraction. What is abstraction? Yeah, abstraction. The term is abstraction.
is something which you cannot see or so it
Huh.
cannot be recreated or
Cannot be recreated. No, not exactly. See, what we did initially for that problem statement, we want to send flowers. What did we do? We tried to simulate how it is done, okay? And then in the process, what we had done is we identified what kind of data types are needed. We have identified that in our problem statement there, we need a type called florist, we need a type called shopkeeper, we need a type called human, we also need a type called flower producer, we need a type called delivery boy. We have identified the types. Not only we identified the type, we identified the kind of interactions for each of the type. This whole process, fine. You don't have to write a code for that, but you need that identification process. The process which does this identification. Fine. No actual code or anything, nothing, no coding done. Okay, that is what is abstraction. You have created an abstraction for your problem. So it's all about identifying the types and the operations for the types. You're not writing the code how the send flowers is going to work. But yes, we have identified that a florist will be there where I need an interaction called send flowers, where this kind of information I should be passing. He will be giving me back some information whenever I do this, maybe. Fine. So that identification process is what we call as abstraction. Okay, fine. Okay, in our programming language called Java, we have a keyword called abstract, but that has a different purpose, so shouldn't be mixed up with that. Okay, abstraction is this process where we do the identification. Right? So abstraction is one. We have another thing called data encapsulation. Yeah, what is data encapsulation? I'm bringing out the terms related to object-oriented programming. What is data encapsulation?
Combining similar
Data encapsulation or data hiding also. You can call it as data hiding. Data encapsulation. When we went to J.K. Florist and said send flowers, what did he do? Referred to a diary. When the diary, is it available to you?
most particularly to
It's there with J.K. Florist. He's not making it available to you. Fine. Okay. See, so there must be a mechanism by which a type should be able to hide what it is actually using inside. To support the operation of send flower, it has to use that diary, right? It's internal to the, it's something which is going to be kept with the JK florist, with the florist object basically, right? The florist object will be using it. It needs it. Okay. Maybe what kind of diary it is using. Today I have got a diary which is a manual one. Tomorrow I might use a electronic diary, or it may be in whatever different form I like, right? Okay, but what is important is, because I'm a florist, I'm supporting the send flowers. To support send flowers, I need some data structures. To support this set of operations, I need my own data structures. And these data structures, I cannot expose them. Fine? Because if the diary was available to all, what would have happened?
they could have done the same thing.
Okay, maybe there's a good relation with the KK Florist and he won't accept it directly from you. You're from Broda, you need to come to JK Florist. That's not so much of a problem. You can even, maybe you can even interact with JK Florist and say, okay, can you give me the name of the florist who is in Kolkata? And he might be good enough to give you that information. So getting information is not fine, publicly is not so bad. What is important is, it's not, If it was publicly available, what would have happened? Anyone could have gone and put any kind of rubbish entries into that diary. And the sanctity of the diary is lost. Right? No one is responsible. Who did that entry? And it's the right which is more dangerous. Okay. And someone being able to manipulate the data structure which is meant for internal use only. Right? So your programming language must have a mechanism by which it prevents direct access to the data structures and use by a particular object. Okay. So that's where we have the data encapsulation. So you can, so data encapsulation, we normally put it like this. We have got some data structure. So we got a data structure here and some kind of a data which is there, and so here is an object, right? So the object is internally using some kind of data structures over here, right? Okay. So you don't directly interact with this data structure. You can interact with the object, and that can maybe fetch the data from here and give it to you. Or you want it to be updated. Yes, he will have some mechanism by which he will carry out his checks whether this is a correct entry or not, and then only I'll make an entry. But he'll not allow you to directly make an entry. Right? No direct access, only by using code. It is you have data encapsulated by code. You have code is your interactions. Those are methods basically. We call them as methods. So only with the help of methods you will be interacting with the object. Okay. Clear? Data encapsulation, inheritance. It's about supertype subtype relationship. Okay, fine. And next thing here is polymorphism. Yeah. So what do we understand by polymorphism? What is polymorphism? Yeah. Okay, polymorphism means poly is multi, morphism is morph is shape. Okay, fine. There are various kinds of polymorphism, and these are mainly related to the interactions. It's more about the interaction, right? See, for example, you have interaction. Maybe I'll have to take a different kind of example. Or okay, even with this, because there are various kinds of polymorphism, just think in this manner that, oh, we have this interaction called how are you, which is defined for all humans. How are you is available for all humans. But in case of a florist, or in case of a shopkeeper rather, okay, when you have this interaction with the shopkeeper will always look at you as a prospective customer, and therefore his response is going to be, where he is going to be extra caring. Okay, he'll say, oh, he has to take care of you in future. So from that point of view, for for shopkeeper, okay, how are you works slightly differently. He looks at it differently. And there can be such a case, right? It's something defined for a super type. Okay, that's a more general one. A subtype will have to support the interaction whatever is available for supertype, but in a subtype he can override that. He can say, okay, this is how is normal for all, but in this I have a special case. The shopkeeper will do it differently and he'll be extra friendly with you. Okay, shopkeeper may do it with a understanding that, oh, yes, I have to be extra friendly here. Maybe it's not the normal one. Okay, fine. So the idea is that interaction is changed in a subtype. When something is going to be, see, no interaction can be denied by a subtype. You are a human, you will have to understand. You will not say, I don't understand, how are you? Okay, fine. But because I'm in this category of the humans, I will do it slightly differently. Some behavior, it's not that behavior is not supported, but behavior is done differently, something done differently. Okay, so for humans, yes, it's this way, but a specialization. So when we have a specialization, there can be a, what we say, specialization of the behavior also. That particular interaction can be done differently. Okay, so that's one kind of a polymorphism. Okay, fine. So actually, to understand polymorphism, we'll have more examples. So this is one case which we say is overriding. There's also another case which we say is overloading. Okay, fine. Overloading can be okay. For achieving the same thing, there can be different kinds of inputs that may be given. I'll just very quickly give a small example for overloading. Okay, we have, for example, we may have a class called plotter. Okay, which can be given, which provides us with various interactions. It says, okay, you can draw a circle, you can draw a rectangle, but you need to provide the proper input. So if you say draw a circle, what inputs will be needed to draw a circle? Yeah, center point and a radius. Okay, but then someone has got 3 points in a plane, right? You know, there is a unique circle which goes through them. So if someone gives me 3 points in a plane, I'll apply that geometry principles and find out what is the center point and radius, and then I'll say, okay, then I'll be able to interact with the plotter and say, okay, now you draw a circle for me. Why not? The plotter says, you can, if you want to draw a circle, you either give me center point and radius. That's one way of interaction. There's another draw circle which says you can give me 3 points in a plane and still be able to draw it. Why everyone should do that same computation? That computation is a standard way how I compute the center point and radius for 3 points in a plane. Okay, fine. So errors in that can be avoided. They can all be located within the type plotter. Okay. Fine. Okay, so yeah, any questions now? Yeah.
So just the introduction of words, right?
Yeah, this is about introduction of object-oriented programming. Okay, fine. What is programming about, and some history of Java. And yeah,
Because like
yeah. Tomorrow, what we'll be doing is we'll have our first Java application. We'll create some practical thing. Fine, we should be able to create a Java program uh, to do something like printing hello world. That's what you did for the in C language also. As a first application, what was it? You said, oh, how to print hello world, right? So we'll do that hello world, but in the process, we would like to understand more about Java. Okay, and we'll get to know more about Java than just saying, okay, printing hello world. Okay, we'd like to see how do we compile, how do we run a Java application, right? Okay, so yeah, I'm not going to talk about how to install JDK. Okay, I expect you to do that. Okay, of course, if you have difficulties, you can come back, right? But we'll not use the time for installation and other things. Okay, and you can always install the latest version of JDK. Currently, it is JDK 19, right? So that can be done. Yeah, sorry. Okay, and so we are done for the day, and we'll Fine. So tomorrow we'll be looking at the what is how do we running our first Java application. Okay, we'll understand about the application itself. Okay.